We will be looking at what is called the average rate of change. What does that mean? It really means just the slope of a line, but we're going to apply that to different nonlinear functions. Well, the slope, you may remember, is y2 minus y1 over x2 minus x1. A fancier way of writing that is in this format: delta y. That little triangle is delta. That means the change in y over the change in x. So f of b minus f of a divided by b minus a. Again, it's just the slope. So find the average rate of change from -1 to +1 using that function. Well, if b is -1, again I'm looking at this formula, then what is f of b, or f evaluated at -1? Well, we'd have -1 squared minus 2 times -1 plus 3. That's 1 plus 2 plus 3, which is 6. Then I have a is equal to 1, so I need to find f of a. So f of 1 is 1 squared minus 2 times 1 plus 3. 1 minus 2 plus 3, I believe that is 2. So if I wanted to find the average rate of change from part A, so part A, according to the formula, f of -1 minus f of +1 divided by b minus a. So f of -1 is 6 minus 2 over -2. So what is that? 4 divided by -2, which is +2. Now let's just connect those 2 points. So if I have, when x is -1, we have 6. See, I could have just done it from the graph. And f of +1 is 2. If I were to connect those dots with a line, their slope would be -2, not +2. Missed my minus sign. Look at the graph. That definitely has a negative slope. So could we do part B from just the graph? Well, let's see. F of 2, okay, when x is 2, what's y? 3. So f of 2 minus f of 5. Let's see, 2, 3, 4. I don't have 5 on the graph, so I would have to evaluate that. So I know it would be 3 minus something divided by 2 minus 5. And I'm going to let you get that answer. And would it be positive or negative? If I had a slope of a point here and somewhere probably up there, not too sure where, would that line have a positive slope or a negative slope? Now that we have found the slope of a line, and a secant line just means it touches a function in 2 points, as opposed to a tangent line, which would just touch it at 1 point. So find an equation of the secant line containing these 2 points. Remember, this is x, this is y. We also have to know an equation of a line formula. So we have y minus y1 equals your slope times x minus x1. I could also use the formula perhaps y equals mx plus b, as long as I know b is the y-intercept of the line. So let's see, if I have x is 0, what is y? Looks like 3. So I have 0, 3. And when x is positive 3, what is y? Looks like it's 6. So I want the equation for that line. Can I use that formula, y equals mx plus b? Do I have the y-intercept of that line? Yes, I do. It is 3. Do I have the slope of that line? Well, we could look at this and say, remember the change in y? Delta y over delta x. So we would have 6, that's the y value, minus 3 over the x values, 3 minus 0. So I have a slope of 1, and that looks right according to the graph. Remember, 1 over 1, rise over run, that kind of thing. So I have y equals 1 times x, and what is b? 3. So I have y equals x plus 3. That's finding an equation of a secant line. Just writing it kind of different, perhaps from how you saw it in a previous math class. Now let's look at finding an equation of a secant line by being given a function and where we want our secant line to be on that function. I have given you a graph, but notice this graph really has no scale, so I really can't just read off the y-coordinates of those points. So how do we find an equation of a line? Once again, we might need this formula, which is called the point-slope formula. Y minus y1 equals the slope times x minus x1. In the previous example, we used the slope-intercept form of y equals mx plus b because we were given b in the problem. But this time, we are not. Remember, b is the y-intercept, and you can see from this picture that this line, we do not know what that y-intercept is. So how do we go about finding an equation of a secant line? Well, the first thing we need is the slope. So remember, our slope is the difference of the y values divided by the x values. So how do we find those y values? Well, we need to find f of negative 1. So I come to my function and I substitute in negative 1 everywhere there is an x. And so that's going to be negative 3 minus 4 plus 1, which is negative 6. So now we have a point when x is negative 1, y is negative 6. The next thing we need to do is evaluate the function at 2. So we have negative 3 times 2 squared plus 4 times 2 plus 1. Remember, order of operations. We need to square that and then multiply. So we have negative 12 plus 8 plus 1, which is negative 3. So my other point is 2, negative 3. So I'm looking at this graph. This is negative 1, negative 6, and this point is 2, negative 3. Before I find the slope, I just look at this picture and I know that this graph, the secant line graph, is tilted upward. So I know I should have a positive slope when I find my slope, just as a double check. So we have the difference in y's. It doesn't matter which order you subtract them in as long as you are consistent. So if I have negative 6 minus a negative 3 over negative 1 minus 2, I just subtracted those two and those two. So I have negative 6 plus 3, negative 1 minus 2, and that of course reduces to the slope of 1. Now remember, I can't use this, even though that's how I want my answers to look like when I'm done. I'm going to need to use that point-slope formula. Well, my point-slope formula says I need a slope and a point. Which point? Do I use this one or this one? It does not matter. Just pick. I think I'm going to pick this one. Has a few less negative signs. So I have y minus my y value equals my slope times my x minus my x value. So I have y plus 3. If I distribute, I have x minus 2. Now I'm going to solve for y by subtracting 3 from both sides. And that is the equation of the secant line that connects these 2 points on this parabola. Now let's look at another example using a cubic function. Again, I have provided a graph, but you really don't need it. The graph is just to help us use a visual representation. When I find the equation of this secant line, the slope should be negative because this line is tilting downwards to the right. So the process is, again, I need to find the slope. So I've got to find my y coordinates. So I evaluate the function at 1. So I have 1 cubed minus 4 times 1 squared minus 1 plus 5. So I've got 1 minus 4 minus 1 plus 5, and that's positive 1. So this point should have the x and y coordinate of 1, 1. Now I'm going to find f of 2. So I have 2 cubed minus 4 times 2 squared minus 2 plus 5. Let's see, that's 4 times negative 416. That's negative 8 minus 2 is negative 10 plus 5 is negative 5. So this point should be 2, negative 5. So again, I need to find my slope. I have these 2 points, and remember I need delta y over delta x. And that triangle is a Greek letter, delta. In math we use for the change or the difference. So again, it doesn't matter what order you subtract them in as long as you are consistent. So I'm going to have 1 minus a negative 5 over 1 minus 2. So that's 6 over negative 1, which is negative 6. That is definitely a negative slope. Now once again, I don't have that b or the y-intercept, so I need to use the slope, the point slope formula for the line. So again, I choose whatever point I want. I think I'm going to use the one that doesn't have any negatives. Looks pretty easy. So I have y minus 1 times my slope, x minus 1. So I'm going to distribute, and I'm going to solve for y. So I have y equals negative 6x plus 7. And that is my equation of the secant line that goes through this cubic function at these 2 points. It's really pretty easy.